Good morning all the examiners. I'm Teo Wen Long. Today I'm going to present about the demo video on topic news event prediction using causality approach on South China Sea conflicts. So first the South China Sea related news article is crawled using the keywords from internet and then using the causality cube such as because, after, since, and etc. All the sentence has been stored in this selected causality news.txt. So after that, all of this data is loaded into the bird annotation tools, which is this one. So first start the bird annotation tool on localhost port 8001, and then all the data set is loaded in here. And then after, in bird annotation tools, I annotate the cause and effects. So this is the binary relation which will be extract later on, and then this is the causal cube that determined determined previously. So after that, all this data will be present in ANN format. So this is the all the data in ANN format, and then using this format, I will look into this VX code, and then here contain the codes to extract all the data sets out. So this is the code that I use to. So first of all, I compare line by line. If detect the sentence have content cause and then content T is the entity inside, then I extract it as a cause, and then for this effects also the same. I extract it to the effects, and then I combine them using the list zip using Python. So here is all the data that I get. So I got two column. One is cause, one is effect. So this one, the arbitrary case, the effect will be called a cabinet meetings. And then all of this data will be load into this, and then after loading the data, so the phase one already done. First one is already done, and then the second phase is to represent all this data into their corresponding sentence representation. So first I load all of this data. So for the test set, I already split to two, which using the ratio of 0.2 means the train data will be 80%, the test data will be 20%. So I already saved it separately for further usage. So for example, this is the test case 1. So I just load the test case 1, and then yeah. So this is the dog to wag model. So as you can see, I load, this is all the initial parameter, and then load all the corpus into the model to train the model for unique embedding values. So this is the infersen I already created for it. So the infersen also, it takes some time to run because the embedding model is using the pre-trained model, which will be more precise on the result as well. Yeah. So this is the infersen. So this is all the initial parameter that I use, and then the pre-trained model that I use for infersen is this crawl 300 dimension from 20 millions of raw text. So for the dog to wag, I already use is a dog to wag model, which is from the GenSim for the GenSim library. And then for bird also, bird is relatively simple. So for bird, I just load the sentence transformer using this pre-trained model, which is bird-based NLI means token. From here, the meaning is that this bird model is a base model, and then is load using NLI technique, and it takes the main pooling token. So this is my quasi similarity function. So as you can see, it take long time to run. And then so this is the finding the similar concept. So this is for three parameter, three embedding technique. So after loading all the models, then I can get the most similar cost phrase for each of the embedding model for dog to wag, for infant, and then for bird. So this is the input cost, and then the most similar cost in the model for this cost is for dog to wag is this one, infant is this one, and bird is this one. So sometimes they are the same because maybe because of the semantic similarity, but sometimes they are not. So for this one is the link effect to the cost phrase, which for example, if input cost is developed bilateral trade tax, so the cost is the refused participated or blah blah, and then this effect is linked to this cost, means this effect will be predicted based on this one because the most similar phrase is this one. So from here, so this is the generated predicted effect for all of the models. And then after I getting all of this effect phrase, I do the ground truth labeling. So I already label all the output here. For 0 is wrongly predicted, and for 1 is correctly predicted. So as you can see here, if for example I have the input cost of develop bilateral type, and then actual effect is seek joint exploration, but then for the other predicted is that pay all money and pay all money. So definitely these two is incorrectly predicted and cannot pose any direct threat. So for example, if I develop a bilateral tax, so definitely it cannot pose any direct threat to the country. So my result for the labeling using causality concept is that dog to wag and infant are incorrect, and bird is correct. So bird is labeled to 1. So for the following is also the same. And then after I load all the data, so here is my result for the 0 and 1. So as you can see here, bird have correctly predicted 19 out of 30, because here got 30, right? So out of 30, and then infant is 9 out of 30, and then dog to wag is 10 out of 30. So for using this ratio, we can calculate the accuracy of the embedding model on getting the most similar phrases. So as you can see here, the dog to wag is accuracy of dog to wag is actually 32, and then infant is 22, and then bird is 61. So here will be presenting using a graph. So as you can see, the graph for the for bird is quite high. So you can see here also, you can see from this diagram, from this diagram, test set 1, test set 2, and then same EWA 2010 task 8 is for the correctly predicted is actually higher than the others. So the accuracy for test set 1 64.2, and then test set 2 is 45.1, and then this same EWA 2010 task 8 is actually a benchmark data set that I use to test my output. So its accuracy is around 42.86. So the average for the bird is 50.85, which is higher than dog to wag and infant. So if after I determine that bird is the most suitable embedding technique that can get the most similar phrase, Then I use the bird to build my causal, yeah, to build my causal model. So here is my causal model. So for example, so this is the causal model. For example, I key in the cause is China won trade war. China won trade war. So I can get the most possible effect is that China won trade war. So the most possible effect will be global security government has suffered a setback, which is logically correct due to the causality, event causality, because if China won the trade war, so uh, global security government is actually facing some problem as well. So this demo shows that I have achieved all three objectives. First, I had all my data represented in tuple form is in cause effect causality pair tuples, and then the second one is that I successfully built all of three embedding model, and then I represent all of these all of these embedding vector for each model. And then the third objective is that I have successfully used the most best fit embedding technique to build my causal prediction model, and then here is the causal prediction model. So thank you for watching my demo videos and hope you have a great day.